Okay. Everybody in? I think one more not in. Who's not in? Hanif, Heba. One not in. Okay. So okay. Let's just open MATLAB lah. Open your MATLAB. Okay. Try to do the example in this step 1 response. So let me just show you how to do it. Anyone never use MATLAB? Never use MATLAB. Denny? Okay.
Use it before, yes.
Shadi, okay. Kugan?
Yes.
Namlami? Already, okay. Arif?
Yeah.
Ain?
Yes.
Yes. Where's Hebar?
Wait.
Okay.
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 Okay, doctor.
All right. So open your MATLAB. I'm using MATLAB 2013. So maybe you guys some are using MATLAB 2015 or 17. Okay. So it's same thing, right? So open your MATLAB. Okay. What you need to do is that based on this exercise. Okay. So we are going to use the coding. So it means that we are going to write it in the script. Okay, before, for 2009 it's called SM file, but for MATLAB 2013 and above, you are going to write it in a script. So go to new script. Okay, this is script. Okay, so what you need to do is that the code here, right? Type it out, everything. Except for the title lah. This one is the title so no need to type it out. MATLAB program motor parameter.m is the title. Okay, no need. It's actually the save. When you save it as that name. So you start with the percentage and then until up to here lah. Okay, type it all out. Okay, and then even for this one, type it out. Okay, assuming that you have typed it out. Okay, so I have typed it out. Have something like this. Okay, I have something like this. This one is for the first exercise. The second part will be for the modified. Okay, so let's do it for the first one, which is this one is to actually declare the motor parameter. Okay, so if I'm looking at my file here, this one is the declare for the motor parameter. Okay, so I just copy it. Put it in my command window. Okay. Enter. So what you see here on the right side is that you see that it's all of the parameter is being declared. Okay, value. IM, KT, KB value and so on. Okay. So that one is to declare the parameter. Next is that we're going to use the transfer function. Okay. This is the transfer function. So which is the second equation, second script here. So I've already write it out. So it's actually I declare of IM, C equals CM. Then this is to actually plot for current transfer function. If you have the symbol percentage, means that it's actually just a note there. So you know that this one is actually for what. Normally, sometimes people write it at the side here. Also can be done. Okay, no problem. It won't run with the program. So I'm just typing out on the top there. Okay, so we are taking this transfer function to run it. Enter. So what happens is that you see that you have the actually generating the current transfer function value. Okay, current transfer function and speed transfer function here. Okay, so next what you need to do is that you want to plot the motor with the step response because you have not insert what is the input to the motor. So we are going to use the next slide, which is this one, motor step response. So we set what the input is the unit step response, 10 volt. Okay, so type it out, take the third, this one, run it, define model parameter. Wait. Oh. Okay, so actually just now, why is it undefined model parameter? That one is actually a node only, so no need delete it. Okay, means that before you run this, you need to define what is the motor parameter and what is the transfer function. So just take this out, run it, then if you see here, it will pop up the graph. So actually what happened is that, okay, if you see here, can you see, is it too small? Okay, so for this one is subplot 211 plot TC means that it's going to plot for the first graph. Okay, and subplot 212 is going to plot for the second graph here. Okay, subplot 212 means what? That's actually the two in the front here is that you have two rows. Okay, you're going to prepare that you're going to plot in one graph is two rows. So next one is that one column here. Okay, the third one here is the position 1. So means that for the first equation here, plot TC here is actually you're going to plot TC, which is current, in the position number 1 here. Okay, therefore, if you look at the second subplot 212 means that the position 1, 2. So it's going to plot here for the speed. That's why plot speed value, you will get this graph. Okay, and notice that, okay, in this graph is that you have the value of TS, okay, caption lah. For you have time here and then current amp here. So this one is how you plot for the label, X label and Y label. Okay, so if you go to the next example is that modified step response. So modified step response, you are using the same parameter, just that you need to modify the input. So I have the coding here. So I'm just going to modify the input value. Okay, click, plot, it's already come out. Okay, you see that it's plotting this graph. Okay, and voltage and current. The thing is that, notice that there's no labeling here. So the task is that to find out how to plot for the label Y and X. Okay, right? So that one is one task. Okay, so we continue with the with our class. Okay, it's on the Simulink. Just now we are using the M file, the script coding lah. We type the coding. Okay, but you can also nowadays people don't use coding using in MATLAB. Sometimes we use coding to declare the parameter, but most nowadays we are using the Simulink. Okay, so example 1 is on the circuit. Okay, a simple circuit, RC circuit. So which is we have with an input pulse with a pulse input DC. So let's just do this equation very fast. So sum of impedance dot IS equal to sum of voltage. So therefore you get this equation. Okay. Then you want to get what is the equation I over Vs. Okay. So substitute value for R and C. Okay, here. Then you will get the value VO over VI means that input over output over input, you will get 1 over RCS plus 1. Substitute value RC, you will get 1 over 0.1 S plus 1. Okay, so right now is that this one is pulse input, pulse. So first is, this is a circuit, then you already found out what is the transfer function. So plot for this transfer function when we have an input pulse. So first of all, draw the Simulink model. Okay, so draw the Simulink model, which is you're going to draw out this. Okay, so having said that, let me close this. So how to go to Simulink? Anyone? Okay, you just give us okay, this one. Okay, the MATLAB main window. Go to this one, Simulink library. Okay, click on that. Okay, so you have the library coming out here. So how to actually start drawing is that go to File, New, Model. Click on that. You get the new model here. So let's start with the, if you see here, you have the block diagram, the transfer function. So transfer function is, open up the Simulink library just now. So transfer function is, we go to continuous and you have the transfer function here, just click and drag. Okay, click and drag. Right, so what else do you have here in your model? You have scope and to workspace, okay, and pulse generator. So find that component. So you want scope. Scope is normally under sync, okay, scope. And then you want the source, which is pulse generator, okay. And then you want just now the sync also, you want it to workspace. To workspace means that, okay, in MATLAB, just now, remember, when you declare the parameter, what happened is that it goes to the workspace here. Notice that, okay? Means that whatever output that you plot, it will actually plot in the scope, but you want it to be actually collected in the workspace like this, okay? So, back again to our plot thing here. So let's go to our instruction. Okay. So you align it. Okay. To actually copy it, right click and drag. Okay. Right click and drag. Right. Sorry. Right click, drag. Then it will copy. Okay. So scope, you can scope here for the input pulse generator. So imagine that this is the transfer function just now. Okay. Transfer function is given by 1 over 0.1 s plus s. So double click that and change the parameter here to 0.01. Okay, plus 1. Okay, so it becomes the transfer function that you want. Okay. Okay, so it becomes something like this. So next is connecting the output to the scope, pulse into the transfer function. Means that this is actually, if you see what type of system is it, open loop or closed loop? Is a open loop, because you have a transfer function, you have just input and output. There's no feedback. Okay, so the reason that you want to have the scope is that normally we don't have the scope connected. Scope is just for us to look at visually. When after we run it, we want to look at scope output. But normally is that we want to collect the output somewhere, right? Because we want to collect it and we want to plot it. Okay, so we plot it in the workspace, which is we are using sim out. Okay, so for the case of this is that if you are just connecting sim out to this transfer function, is that you are going to plot only for the output. But for the case of control, normally we plot input and output. Okay, therefore for the model is that we are going to use the where is marks? Signal routing is under signal routing. So we are going to use marks. Marks is actually, okay, the one this. Okay, so we are going to collect output and we want to also collect the input. Okay, so this both we are going to collect it to the workspace. Right? So for the case of to compare to get the output plot, we just drag the scope to both two ends, input and output. Okay, so we have completed draw the Simulink model here. Okay, next is that we have not finished. We just now set up only for the trans function. Now we need to set up what is the pulse generator. For this case is that it says an impulse input. Impulse, it's not a rectangular input continuous. It's just impulse, one pulse. Okay, so it give you here. Okay, set the amplitude. Set amplitude 12. Set it to 12. Period. We want to run it for 1 second only. Pulse width. Normally, if it's a rectangular signal, it's 50%. Okay, for this because it's a pulse only. Okay, so we set it 2%. Of course, you can set it 1%. Okay, but now we set it 2%. Phase delay, there's no phase delay, 0. So apply. Okay. Right. What else? Okay, save format, sim block to array. So sim block, it's important to actually set the sim block to the correct format. So we don't want time series but array. Means that when it plot, you will plot in Excel file. One column is for the input, another column is for the output. Okay, so apply. Okay. Okay, this start time, stop time, set it to 0.1 second. Okay, done. Done. Save it. Save. Okay, save it and run. When you run, notice that in your MATLAB, this one, MATLAB here, this part, you will see that you declare here the input sim out. So the name is sim out the data. So find out in a workspace where is sim out. So this is sim out. Double click that. If you click, there will be two arrays, two rows. Row 1 and row 2. Row 1 will be the input just now, the impulse. Row 2 will be the output plot. Okay, so close that again. And then, if you want to look at the data, then just double click, see what is the graph. So this one will be the graph of the output. Okay, and the pulse will be something like this. Okay, pulse. Okay, anyway, you cannot see it much because you need to set the scope to the correct formatting. So if you want to plot the data from workspace, okay, use the plot sim out, or you can just type it here, plot sim out. You will have the plot, the graph like this. Okay, means that the blue, actually you cannot see it from 0 here, but it's actually moving up. It's the impulse, and then this is the output. Okay, which is, if you look at your circuit, it's actually represent the RC circuit, right? Because when you charge, you give input voltage, what happens that it's going to charge up, and then after this output is done, then it's going to discharge. Okay, so that one is example of an RC circuit when you do the modeling using Simulink. Okay, so Now we go to the Simulink part 2 for the torque of motor. Okay. So remember I have explained to you how we get this transfer function. Okay, we have the mechanical part, we have the electrical part here. Okay, so this exercise, this is just a recap. This slide is just a recap from the previous slide. Okay, so just look at this SRT, which is what you need to submit later on. Okay, based on this setting, draw the Simulink block diagram module. Okay, so use the transfer function, label this everything. Sorry. Okay, label this and so on. And then substitute this parameter into this value. So you can either use declare this parameter like what you declared in MATLAB just now, declare everything. So what you need to do, what you just need to do in Simulink module is that instead of instead of setting it as this value, you may set it, for example, for this case, LS plus RA, right? So you set it as L RA. Okay, so you do something like this. Okay, then if you use this transfer function, then you need to declare in here, declare first what is LA equal to what? For example, 2, and then R equal to 5. So it will declare in this workspace. Okay? So your task for this chapter is to actually draw this module and then declare this function. Okay, saturation block. Make sure that this saturation block you can find it in Simulink library. Set it to -4 and 0.4. Means that sometimes when you give an input, torque will actually go up to a certain value, maximum torque. But you do not want that to apply to your mechanical parts here, which is you have the damping and the damper and the mass value. So you want to set it at a certain saturation block. Maximum it can go up to 0.4 and -0.4. It's similar concept when you have an actuator. An actuator, actually the coil will only withstand to 2 ampere, plus minus 2 ampere. So you don't want to exceed to 3 ampere. So you set it as a initial saturation point. Means that if you were to actually apply the step here, more than 2 ampere, then it won't go up to 2 ampere. It will cut off that value. Okay, so this one is for safety. Okay, for safety reason. So saturation, we normally put it in the beginning here before we go to the actuator, which is the mechanical part. Okay, so step block diagram, set it to 0, 0 and 10 means that the starting value is 0, maximum value 10 means that step input is 10 lah, 10 volt. Okay, save the sim output as array. Okay, array because we are going to collect 2 different value, which is the output here, and also the value from after the constant. Set the stop time means that the Simulink model run it to 0.1 second only. Okay. Okay, so that will be your exercise, okay, or assignment for this. So you need to plot for the graph, okay, for the graph and label all the graph equally. Okay. Any question?
No.
No. Okay, we are finished the chapter actually. So we go round table. Zam-Zam.
Okay.
Okay. Okay, Shadik.
No.
Kugen.
No.
Ain. Okay. Hanif.
No, madam.
Jadi.
No, madam.
Arif.
No, madam.
Eva. Are you in your room? Okay, so far? Okay. So
Okay.
the exercise just now for the modeling, for the Simulink, okay, submit it next week lah. Okay, next week by, I think you can submit it by Monday lah, Monday. Okay, so
Okay.
the same email. So maybe you can just separate it out. So for the part 1, what is the assignment? Part 2, part 3. So 3 file, different file that you need to email to me.
Okay. Can I know what's the exercise for part 2
Part 2,
that we need to submit for you?
this one, to plot the graph. To plot the graph for using sim out. Okay, similar to this. Okay. If you can actually draw this model, you can draw this model, draw this one, and then assign this, and then plot for sim out. Then I assume that you understand the concept of how to transfer from you when you have an electromechanical system. You learn how to actually derive the mathematical modeling. Then you get the mathematical modeling. You can actually draw out the block diagram like this. Then from here, assuming that you have the value for LA, RA, KT value, okay, then you define it, you declare it, then you can give any input. This one is example as the input. Of course, you can try out with different input. You can try it with sinusoidal input. What happened to the output? Okay, but for this case is that I'm asking you to just using step input. So plot for the output response. Okay, for this point, this 2 point means that at this point and this point. Okay, so means that before disturbance lah. Okay, alright. That will be all. Okay, so tomorrow class will be at 9:30. Class notes I have not upload email yet. I will email maybe by tonight, okay, because we have you know the Prime Minister just announced yesterday kan, so I didn't get to finish my notes yet, half part, so I try to finish it. So by tonight I will email it to Ain and Sadiq lah, so you they will pass it to you guys. Okay, so that will be all. Okay, so see you guys tomorrow at 9:30. Okay, Assalamualaikum warahmatullahi wabarakatuh.
Doktor.
Bye.
Doctor.
Madam.
Bye.